What's the next hot thing in the crypto space? Well, that's the million-dollar question for lots of people. And there's a really popular idea going around about soulbound tokens as proposed by the creator of Ethereum, Vitalik Buterin himself, about a new non-fungible token standard that could completely change how we use blockchain as we know it. I just put out a video recently talking about these soulbound tokens and why they could be such a big deal. And in this video, you're going to learn how to code one yourself with Solidity smart contracts for Ethereum and other EVM-compatible blockchains. And if you're not 100% sure on what a soulbound token is, definitely go check out that video if you haven't already. But in this video, we're also going to cover the quick concepts before we start coding. So I'm super excited for you to learn this. So if you're new around here, hey, I'm Gregory, and on this channel, I turn you into a blockchain master. So if that's something you're interested in, then smash that like button down below for the YouTube algorithm and subscribe to this channel. And if you want to know how to master blockchain step-by-step start to finish, then head on over to dappuniversity.com/bootcamp to get started today. And if you have been watching this channel for a while, then definitely welcome Victor. He's one of the newest members at the Dapp University team. He's going to present on this topic today, explain soulbound tokens and how to code one. So let's jump in and get started.
Hello everyone, today we're going to explore a new token standard called soulbound. We'll see what are the use cases and code a soulbound token ourselves. So what are these soulbound tokens and why do we need them? What's the benefit? So at the moment, in the Web3 space, there is no native Web3 identity that you have, and this makes the entire DeFi ecosystem unable to support activities like we have in the real world, such as under collateralized lending or simple contracts like an apartment lease. And basically these soulbound tokens would represent your digital identity. They would be a representation of your skills and qualifications. They would be publicly visible, and under the hood those will be NFTs, but non-transferable NFTs, which means you cannot trade them and send them to other accounts. So these soulbound tokens would help users gain insights into others' accomplishments, credentials, what they like, dislike, their skills and qualifications. And with these tokens, we would basically make incremental step towards representing a social identity, and we could potentially overcome limitations such as not being able to do under collateralized lending. And the first time they were ever mentioned was by Vitalik Buterin himself on his blog. So this is the blog post if you want to read more about it. Vitalik Buterin actually and two other people have written a paper on these soulbound tokens that you can find here. And here in the paper they talk about all the use cases and how these soulbound tokens will help build a decentralized society, and how all of the many core economic activities like lending and building personal brands are built on non-transferable relationships. And currently there is no standard for this like the ERC-20 that you can build off of. There will be one probably coming out in the late 2022, so this year. But we'll actually try to code a non-transferable NFT ourselves in this video. But before we do that, let's go ahead and see all the use cases of these soulbound tokens. The first one being education. So at the moment, universities, upon graduations, give out paper degrees to students. And whenever you want to start applying to jobs, potential employers kind of have to manually contact you and verify that you have legitimately graduated from this university. But what if universities could use soulbound tokens to award graduates a degree as a soulbound token, and the owner wouldn't be able to sell or transfer this soulbound token, just like you wouldn't want to sell your degree in the real world. And these soulbound tokens are non-transferable by design. And since everything would be on-chain, it would be harder to fake it, and it would be easily verifiable by the employer, since they can just go to your wallet and see if you have the degree or not. And we will actually build this university contract. And you can imagine the university like Oxford have the contract address on their website, so you know their real contract. And also some people were concerned that they would be just sent out some random soulbound tokens to their wallet that they didn't want. And this is easily solvable by just having a sort of permission. The contract, the university contract, would just give you permission, or it would issue a degree, so you can later claim the degree by yourself. And this way we would avoid this sending out soulbound tokens to your wallet that you may not want. Another use case for soulbound tokens are just proof of attendance. So let's say you attend an online class, so the teacher can just hand out soulbound tokens to prove your attendance of this course. Let's say, for example, or even it can be all the Ethereum core developers that contributed to the Ethereum ecosystem or attended a developer conference can get soulbound tokens. Another really useful use case for soulbound tokens is just using them in decentralized autonomous organizations. And these DAOs, as the name suggests, are organizations that are autonomous. And these are just smart contracts on the blockchain, so the entire organization is run by code, where people can come in, join the organizations, and vote on how decisions are being made. A really common use case for DAOs is just the DAO being an investment fund. So people would invest small amounts of money into this fund, and each person would have sort of like a voting power and contributing on the decisions that are being made. So basically, where do you want to invest the money, in which stock? And in a lot of DAOs, the governance power or the voting power is transferable. So they use something like a token in ERC20, which means you can easily buy voting power. And this is a problem because institutions or just people with a lot of capital can buy more voting power and make the DAO be centralized. But if the goal of the governance is to be widely distributed, then transferability is counterproductive, as these people, the whales, can buy governance and voting power from these other people. And soulbound tokens can change this because these are non-transferable NFTs. And so basically when you would simply decide, the DAO will decide to give out these non-transferable tokens to the people that are most competent and have the best interest for the organization. And this way, the whales or institutions with a lot of capital wouldn't be able to just buy the voting power and make the organization more centralized. Not only these people can sometimes not have the best interest for the decentralized organization, but they can also, if they have most of the percentage of the voting power, they can do something like a governance stack. So the soulbound tokens would really solve these issues, because the governance rights would be forever fixed to these people because it is non-transferable. Another huge use case for these soulbound tokens is under collateralized lending, which is the only lending type of lending that we have in the real world. But because in blockchain everything is private, is anonymous, no one knows you and nobody trusts each other, which means we have over collateralized loans, which means you need to put more money into the protocol than you are borrowing. But in the real world, it's completely opposite. You just, for example, if you're buying a house, you're just putting something like 20% down. And we are able to do this in the real world because we have things like credit score. So if the bank knows that that in the past you have been responsible and paid out your loans and you have a high credit score, then they will loan you money at a lower interest. And this is another use case for soulbound tokens. So what if you were to use the Aave protocol? Once you take out a loan at Aave, they give you some soulbound tokens that represent the debt that you have. And once you return the loan, you have been responsive, you have returned the loan on time. Aave will give out internationally sort of recognized soulbound tokens that you have used their protocol and sort of give you like a credit score. So later when you want to use the compound protocol, they can see, hey, they can see your wallet and they can see that you have some soulbound tokens from Aave. And they can see that they have a credit score. Of course, this doesn't mean that you will responsibly pay out the loan at compound, 100% guaranteed, but it proves some credit score and credibility. And if you paid out all of your loans on time in compound, later when you go to other protocol like Curve Finance, then you have even bigger score. So now let's try to develop a soulbound token. As I said previously, there is no standard, but we will create an NFT that is not transferable. So we'll create our own version of a soulbound token. And for this we'll use the Remix IDE. This is an online IDE that allows you to develop, compile, and deploy smart contracts to this local blockchain that it is built into Remix, or we can use testnets. And testnets are the closest things we have to the real blockchain, meaning these actual testnets have nodes that run them. So you want to open Remix, you want to go to remix.ethereum.org, and we have like a file structure here, like we would have into a local IDE. And inside this contracts folder, I'll create my university contract by right clicking new file and then just saying something like university degree. So once we have that, this will create a new Solidity file that in which we can create our soulbound token. And the first thing I'll write is a comment that just specifies under which license we're writing this code. This just so we can escape this warning. Then I'll provide the Solidity version that I'll use using Pragma Solidity, and I'll use any version above 0.8.0, and at each line we have to put semicolons, and any version above means that we need to add this sign. Then I can create the contract using the contract keyword. We might as well close this, and I'll name my contract the same way I named the file. This doesn't have to be, but it's not a must, but it's a good practice. Then what I want to do is to create my NFT is I'm going to use already an ERC-721 implementation from the OpenZeppelin library, and specifically I'm going to use this contract. And to import this, basically it has all the functionality we need to create an ERC-721 collection. So to import this, I'm just going to copy this, go into Remix, and just say import, and then inside these we want to paste what we've copied, and instead of saying OpenZeppelin contracts, I'll just remove these contracts, and there we go. And we also need to add sign here. And we will actually use the 0.8.2 version and any version above. So this is the contract we use for the NFT, and also we're going to use another contract from OpenZeppelin once again called counters, and this is just a class, or I should say, or a library that will count the NFTs or the degrees we get issued as we mint them. So if I go back to actually import this, I'm going to import it in the same way. So copy this, go into remix, just say import, and then we want to paste this in, add sign, and then delete these contracts, save this, and then see if it compiles and if you get any errors. So now to inherit from this contract, I'm going to say is ERC721 storage, and inside here we want to specify that we will use this counters contract by saying using counters for counters.counter. Then I want to create the constructor, and this is a function that gets called only once when you deploy the contract. And inside here we need to call the ERC721 constructor that we get from this contract. So this constructor will get called first, and then this constructor that we're currently implementing. And inside here you want to this constructor takes in two arguments, the first being the NFT collection name, which will be university degree, and in the second argument it's just the NFT collection symbol, which will be just degree. So this university basically has some sort of like an owner, will create access control, so not everyone can just randomly issue degrees. And for this I'm going to set up an owner as an address, and this owner and only this owner will have the right to issue degrees. So I'll create a function called issue degree, and this will have an address to which person we are issuing a degree. And what this contract will have is a mapping of addresses to Boolean. And what will this do? This is basically recording which addresses have a degree issued. And once this is set to true to some address, a person with this address can come in and claim their NFT, and we'll create a separate function for that. So this will be public, and I would call this issued degrees. And don't forget to put semicolons, and inside here I want to just access this issued degrees mappings, and I want to use these brackets, use this address, and set this to true. And this is how we issue degrees, but this function should be only called by the owner, and also we need to say external here. And how can we make sure that this is only called by the owner? We can specify a modifier, and a modifier is just a piece of code that you call before this function code gets executed, and you just attach them to a function. So just define a modifier, we'll call this only owner, because that's what it does. And inside here we will require that the message.sender, basically person who's executing this code or this function, because we're going to attach this modifier to this function. So the person who called this function needs to be the owner. And how do you know which person is the owner? Well, we're going to set in the constructor that the owner is the person who deployed the contract, which is message.sender. And this will run only once we deploy, when we deploy the contract. And also in this modifier, what we want to do is just put an underscore like so, and this represents all the code in this function that the modifier is attached to. And how can you attach this modifier? Well, you just need to say only owner right here. Now let's create the claim degree function. This will be called by the students who have graduated. So create a function claim degree, and this will take in a string which will be stored in memory, and we'll call this token URI. And this is basically the link at which our degree is stored, and we haven't created the degree yet. We'll create this and host to IPFS, but let's make this function public so anyone can call it. and we'll say that it returns a Uint 256, and this will be just the unique token ID of the NFT, and this is what we use these counters for. And I actually create a token IDs variables for all the token IDs for our NFTs, and of course this will be of type counters.counter. So who can claim an NFT here? So we'll require first that the person who wants to claim this NFT actually has the permission. Actually, the university has issued a degree to him, and to check this, we'll access this issued degrees mapping with the address of message.center. This is the person that calls the contract, and if there is an error, we'll just throw an error that says degree is not issued. I'll add just an underscore in this token IDs variable, and I want to, whenever a new NFT is minted, I want to access this and increment it by calling the increment function. And this is what is provided by this counters class that we imported. And also what I want to do is call the mint function with the person that calls the contract, and with this new item ID, which is the current token ID, and we get this by calling token IDs.current. Since we have incremented this, we call set token URI, and finally we'll return the new item ID. This is the ID of the NFT being minted, or the degree being issued. Now what we may also do is just say issued degrees and set this to false from the person that minted this NFT, so he cannot mint this twice. And also I would add additional mapping and just call this person to degree. This will be for any third party, for employer, etc., that has the address of this person and wants to see their degree. So this will be useful for them. They'll just have to call this function of this smart contract. So this will be map address to this string, and this string is basically the link of the degree, and this will be public, of course. What we want to do is just say person to degree now, just set the token URI of our NFT to here, and that's pretty much it for the actual contract. So now let's go ahead and create our NFT. And now to create the NFT is actually just a JSON file that you can just create inside terminal, or as I've done it, as I've opened it here inside Visual Studio Code. And this JSON format of data is just this object in curly brackets, and inside here we want to add some key value pairs. So this NFT or degree will have an image, and this image I've created, you can use any image. I have actually uploaded to Pinata, and Pinata is just a software that allows us access to IPFS, and IPFS is a decentralized way to store data. So that's what we are going to use, and we are going to upload this image for our degree by clicking upload, file, selecting your image as I have done here, and any item, any data that you upload to IPFS, you get a CID, which stands for content identifier. And what we want to do is copy this content identifier, go back into our NFT, and just provide this image here. So just provide this key, and the value will be the actual link of the image. And you want to paste the content identifier here, and we have this part of the URL, which means this just means it's stored on IPFS. I have added some description here and also some attributes. This is an array of objects, and this is how you would define them. The trade type, we have the GPA, we have the major, and the type of degree. So I would also upload this to IPFS. And now to mint this, so basically what you have to do, you can see actually this NFT. If you just click here, it would open the NFT, but you can also visualize this on OpenSea. So let's first try to mint the NFT. And how can we mint this NFT? So go to Pinata, copy the CID of the NFT, and I will deploy this contract to the Polygon Mumbai testnet. And for this, we have to select the environment as injected Web3. And in our MetaMask, we have to select the Polygon Mumbai testnet. And then just click on deploy. And make sure you have some testnet Ether inside in the Polygon blockchain, because you need some testnet. This is free Ether that you get from a faucet, because you need this to pay for the gas fees. So confirm the transaction, and just my account basically now is like, you can imagine it being the person, some person from the university, and now I can issue degrees. And now let's say this is the account I have deployed this contract. So now let's say I want to issue an degree to this second account. So I'm just going to copy the address of this second account and go into issue degree function. I'll zoom in so you can see. And this takes in the address of the person that you want to do this. And make sure that this account is selected. The account that you have deployed your contract, the account that's the owner of this contract, because you wouldn't be able to issue degree if you're not the owner. So now you can click on transact. So now we are trying from our owner account, from our first account that we used to deploy this contract, to issue a degree to our second account. So confirm the transaction. And now to mint, to claim this degree, once it is issued, what you have to do is copy this CID and just create this URL, paste this CID here, and with this URL that you have of your JSON file, you can now claim your NFT. So go into the browser, Remix, and you want to call this claim degree function from your student account. So copy that link and go to claim degree. This takes in the token URI, or basically the link to which this degree is hosted. Make sure you are from your student account and click on transact. And after we've claimed the NFT, we can go on testnets.OpenSea, and inside profile, we can see our minted NFT. So this is the image in our JSON file, and these are the properties. The major is master of business. We have the GPA 3 out of 4. But now if you were to try to transfer this NFT, you would be able to. And how can we make this non-transferable? So go back into Remix, and what you want to do is we want to flatten this contract. Basically, we want to see the code of both of these contracts, actually only this one. So how can we do this? So if you go into plugins, we want to activate this flattener plugin. And what will this do? It would flatten the contract just like so. So we will still have the code that we've written, but we'll also have this library counters, and we'll have a lot more code, because now we can see all the code that we have imported. And what we want to do here is search for the save transfer from function, because this is what OpenSea uses to transfer the NFT, and we just want to remove this function. And once you remove this will be a non-transferable NFT. So if you were to deploy this contract once again, try to transfer, you would get an error. So that's all I have for you today. If you want to learn more about blockchain and become a full-time blockchain developer, make sure to watch the courses that we have on the homepage in the Dapp University YouTube channel. Or if you want to take a massive shortcut entirely, go to dappuniversity.com/bootcamp. And thanks for watching Dapp University.